Once a scientist named Benjamin Franklin had a shocking encounter that changed our world. In a daring experiment with a kite and a key, he uncovered the mysteries of electricity. This incredible discovery led to countless marvels we now enjoy, like the bright lights in our homes and the gadgets we can't live without. So, let us explore various concepts related to electricity that power our world. In this video, we will explore the concepts of electric current and circuits, as well as electric potential and potential difference. Let us start with electric current and circuit. Imagine standing by the bank of a river or a water channel and watching the water flow. Now think of that flowing water or water current in a channel as if it were electric charges moving through a wire. Electric current, in simple language, is the flow of electric charges, usually electrons, through a conductor, like a wire. Just as the flowing water in a river needs a continuous path to maintain its movement, electric current also requires a complete and uninterrupted circuit for the flow of charges and the proper functioning of electrical devices. A circuit is needed for the flow of electric current because it provides a continuous and closed path for the charges to flow. This allows the electric current to travel from a power source, like a battery, through a conductor, like a wire, and power a device, like a light bulb. When a switch is turned on, it connects the different parts of the circuit, allowing the current to flow and the device to function. If the circuit is broken or the switch is turned off, the current stops flowing and the device will not work. Now that we have recalled the importance of electric current in our lives and its connection to natural patterns, let us explore how we can express and represent electric current. Electric current, in simple language, is the flow of electric charges, usually electrons, through a conductor, like a wire. The direction of electric current is considered to be opposite to the direction of the flow of electrons, so, historically, it was thought that electric current is the flow of positive charges. Mathematically, electric current, I, can be expressed as the amount of charge, Q, that flows through a particular area in a certain amount of time, T. The formula for electric current is I is equal to Q by T. This means that the electric current is equal to the charge that flows divided by the time it takes for the charge to flow. So, you can also imagine electric current as a rate, how fast the electric charges are moving through the conductor. Now let us study the measuring unit of electric current. The measuring unit of electric current is called an ampere, named after the French scientist André-Marie Ampère. It is derived from the flow of electric charge, which is measured in coulombs, and number of electrons contained in 1 coulomb charge are 6 times 10 to the power 18 electrons. That means 1 electron carries a negative charge of 1.6 times 10 to the power minus 19 coulomb. Now, 1 ampere is defined as the flow of 1 coulomb of charge per second. And smaller quantities of current can be expressed in milliamperes or microamperes. An instrument called an ammeter is used to measure electric current in a circuit, and it is connected in series with the circuit components. Now you understand what electric current is, but did you know that the current cannot flow by itself? To discover what causes the current to flow, we need to explore our next topic: electric potential energy and electric potential difference. Let's first break down the concept of potential in everyday terms. Potential refers to the capacity to accomplish something. For example, a ball at a certain height possesses stored potential energy, which allows it to fall down when released. In the same way, electric potential is the capacity or energy stored that allows electric charges to flow, resulting in an electric current that powers our devices and appliances. When a ball is kept at a height, it has high potential energy. Similarly, when a positive charge is kept near a positive charge, it has high electric potential. Now analogous to a ball which naturally moves towards the ground when released and the potential energy of the ball is converted to kinetic energy, a positive charge at high potential is drawn towards a negative charge at low potential, and electric potential energy of positive charge is converted into kinetic energy. Therefore, just as a ball falls from a higher elevation to the ground, current flows from high potential to low potential. This potential difference is typically generated by a battery or an electric cell through chemical reactions that produce a voltage across its terminals. In mathematical terms, the potential difference between 2 points in an electric circuit can be calculated using the formula V is equal to W by Q, where W represents the work done to move a unit charge between the 2 points, and Q is the charge being moved. This means that the potential difference is directly proportional to the work done and inversely proportional to the charge. Now, what is the measuring unit of electric potential difference? The measuring unit for electric potential is the volt, named after the Italian physicist Alessandro Volta. It is derived from the potential difference between 2 points in a conductor carrying an electric current. 1 volt is equal to the amount of work done, 1 joule, to move a charge of 1 coulomb from one point to another. In simple terms, 1 volt is equal to 1 joule per 1 coulomb. The instrument used to measure potential difference is called a voltmeter. It is always connected in parallel across the points where we want to measure the potential difference. In conclusion, electricity can be imagined as a city filled with energetic electric charges that flow through circuits to power our world. Electric current, measured in amperes, is the flow of these charges, while potential difference, measured in volts, is a driving force that keeps them moving. Now that you have understood these important concepts of electricity, open the EduRev app where you get video lectures, chapter notes, and MCQ tests for this chapter. EduRev also provides you amazing courses for maths, social studies, English, Hindi, and many more. Thank you.